In this skill, we're going to be looking at the different parts of a nuclear reactor, which is what makes up a nuclear power plant used to generate electricity. So we're going to look at each part of the nuclear reactor. Firstly, labeled A here, we have our fuel rods. The fuel rods are made up of uranium-235 atoms. When uranium-235 is bombarded with a neutron, it splits to form two smaller atoms in something called a fission reaction. That reaction releases several neutrons and it releases energy in the form of heat. So that's our fuel for our reaction, uranium-235. The way we generate power from this is using the coolant, which is labeled D here. This is the coolant flowing through this pipe here, labeled D. The coolant is a liquid that flows past our reactor and it absorbs the heat from the reactions that are happening in the fuel rods. That heat is then used to heat up water so that it boils to form steam. The steam then turns a turbine, which generates electricity. So this is how our nuclear reactor turns nuclear energy into electricity. That's the basic idea of how the nuclear power plant works. However, we have several other features built in. One of them is the graphite moderator, which is labeled by C here. It's this whole section in here. That's the graphite moderator, made of graphite. It's called the moderator because it moderates the speed of the neutrons. So I already told you that when uranium-235 gets bombarded with a neutron, it then absorbs the neutron and splits into two other atoms, plus some more neutrons, plus energy. But it can only absorb a neutron that's moving slowly enough. So the purpose of the graphite moderator is to slow down the neutrons so that they can be absorbed by other uranium-235 atoms. Now, a problem we might have here is that every uranium-235 that splits forms multiple neutrons. If all those neutrons went on to cause another fission reaction in another uranium-235, pretty quickly our reaction would get out of control. That's called a chain reaction. So we have these control rods labeled B here. And you can see there's those arrows showing those rods are moved in and out. What the control rods do is they absorb neutrons to take them out of the reaction. So they absorb a neutron that will not go on to cause another uranium-235 fission. So if you want to speed up your reaction, you can pull out the control rods and all the neutrons that are produced will go on to cause other fission reactions. If you want to slow down or stop your reaction, you can push those control rods in and they're going to absorb the neutrons produced in each fission reaction to prevent them from going on to cause other fission reactions. So the control rods are for controlling the speed of the reaction and making sure it doesn't get out of hand. Lastly, another safety feature is the concrete shield that is around the outside of our reactor. Labeled E here. The purpose of the concrete shield is just to prevent any radiation from getting out into the environment. So it's going to absorb any radiation coming from inside the reactor to prevent it from going outside and potentially causing damage. So that's all the different parts of the nuclear reactor. In this question, we're asked which letter labels the control rods on the diagram. Our control rods here are labeled B. So we can go ahead and select B as our option. We're then asked which best describes the function of this part. We know the control rods are used to absorb neutrons to take them out of the equation so that they don't go on to cause further reactions. So that looks like it's going to be option 1 here. Absorbs neutrons to prevent a chain reaction from occurring. That is true. So it's going to be option 1 here. So in this question, all you need to do is recognize each part of your reactor and know what it does.